Surprisingly, a lot of people have asked me to do this paper. It's from 2016. You're given 180 foots to do it in, so we'll just see how it goes. Cow number one then, got a complex number 1 plus 2i. We're just going to find w being 2 of that complex number plus the conjugate. The conjugate is just 1 minus 2i, of course. So very straightforward. We just work it out. We have our answer. And we're now told that log space 2 of x is root 2, and we're being asked to evaluate this thing here. Now, to do this, we're going to have to break out, I think, well, I mean, firstly, we can put the 2 over here and the 3 over here by the power law for logs. But we can also use Taylor's change of base law, which says log of base something to something else is just a new log, whatever you want it to be. And then this one goes at the top, and then this one goes at the bottom like this. This is the Taylor change of base law. So, okay, log to base a half of x is just log to base 2 of x divided by log to base 2 of a half. And log to base 2 of a half is just minus 1. And this one over here I've also changed to be log to base 2. Log to base 2 of 4 is just 2. And so we'll end up with, it's dividing by 2, so it makes a half, and then this one just changes this to a minus here. And of course we can just put those all together and we end up with our value for A. Good. Cow number 2 then is just asking us to sketch this graph, doing all the normal things for sketches, so just intercepts with axes and then also some turning points labeled down. So factorize out the x squared, we can see a root at 0, we can see a root when we factorize this to root 2 and minus root 2, so that's fairly straightforward like this. It's an upside down quartic, as we can tell from this, so it looks like this. We'll label our roots. I should probably have put a 0 here, but I couldn't be bothered. The turning points then, so just differentiate this and we'll get this. Set that to be 0 and solve that, we'll get x is plus or minus 1. And then put 1 into here and you end up with your 2 turning points there, and we should be good to go. Cow number 3 then is telling us that this cubic here has 2 stationary points, and it wants me to show, or it wants me to find the value of m such that the 2 stationary points do this. So okay, differentiate it and set to 0 to find stationary points. You can solve that in terms of m by getting out the quadratic formula. We know the 2 stationary points are x1 and x2, so x1 will use the plus and x2 will use the minus. And yeah, we'll just need to put these two things into here to make this happen. And we'll solve this for m. Now 6 squared is 36, so I'll just times everything by 36 to make this. Now we can square out, remember to expand brackets carefully, 6 times 6, and then 6 times this, and then this times 6, and then this times itself. Eventually you end up with all this. There's a bit of cancelling, which is nice. You get all the way down to here if you're careful about things, and you get m is minus 1.5, I believe. Or 3 over 2, whichever one you want to say. Cow number 4 is just asking us to do this integral. This is fairly straightforward when you realize if you just expand the brackets out like this one here becomes really nice because it's of the form f dashed of x times f of x to some power. So I can just use reverse chain rule. So obviously this one is super easy to integrate. But when we raise this to a 3 over 2, this x means that it is really good because it's the derivative of this 2x here. So I just need to balance these things out. So if I just stick a half in here, that will undo the 2 that will come down when differentiated. And I also need to put a 2/3 in to undo the 3 over 2 that's also going to come down when differentiated. And I think this is good to go. We'll just evaluate that after simplifying a little bit. Put in the 3, put in the 0, and we end up, I can't bother to do this properly, but we end up with something that works quite well, I think. And we get our answer, which is nice. Cow number 5 then, we've got a coordinate space x, y, z, so 3D coordinates, got points in the space of A, B, and C. It wants us to find the plane that goes through A and is perpendicular to B and C first. So, okay, let's do that. So B to C, well, you just add 1 to the X, you take away 1 from the Y, and you add 2 to the Z. So B to C is this. Plane that's perpendicular to that will be of the form this X plus this Y plus this Z equals K. For some K, we can find K just by putting in A because it tells us it goes through A. So put in A and we end up with this, and we'll find K very easily. And we'll have our plane there. Next is asking us to find the coordinate where that goes through BC and is perpendicular to the line at A. So a bit like this, right? So if you project from A to make a perpendicular angle with BC, find the coordinates of that point there. So BC, as we discussed, the line BC we could say is of this form here. So this is just the point B and then plus some amount of the direction B to C. Which means, of course, you can write D as just combine these two things together, and you can just say this is the point D for some m, which I'll find later. Now, A to D, of course, A to D we can just write a bit like this because we're going from here to here. So we can just do this minus this and this minus this, and this minus this. So this is the line, or the vector a to d, I should say. And now, of course, a to d is perpendicular to b to c. So if we take this vector here and this vector here and dot them together, we should get 0 because they're perpendicular. So okay, we do this times this plus this times this plus this times this, and I think we'll end up with this, which will give us this, and that means d is 0, 0, 1, I guess, minus 1, and we'd be good with this question. Question 6, very straightforward, and we just solve this. It actually just factorizes, right? So that's cool. You say either this is 0, which means sine of x is a half, or this is 0, which means sine of x is minus 4. That can never happen across the real numbers. Although it hasn't actually told me we're working only in the real numbers. It also hasn't told me whether I'm using radians or degrees, or what range of values to solve for. It has given me something about hyperbolic trin, and I'm not quite sure what that is, so someone better at maths than me is going to have to tell me what that's about. But anyway, we're going to solve this, obviously. I did radians, and I did the first two, and I just stopped there. Part 2 of Cal 6 is interesting because it has nothing to do with Part 1. It's saying a student has created some kind of passcode to open a door, and his system, you've got the numbers 0 to 9 on the keypad, and the system is you've got to type in 3 numbers which are increasing in value, strictly increasing in value, and the 3 numbers have to add up to 10. So, for example, this would be a correct code for his door because the numbers are strictly increasing and they add up to 10, and there's 3 of them and they're all different. Then it says student B comes along and just randomly tries to open the door by typing in 3 different numbers. What's the probability that he manages to open it? Well, the number of things you could type in, you've got 10 numbers to choose from. So if you're just doing this randomly, 10 choices for the first, he's selecting different ones each time. So 9 choices for the second, 8 for the third, gives him this many choices in total. We can actually just list the correct passcodes because there's not a lot of them. Start at 0 and increase, and these are the only ways to add up to 10. There's only 4 of them. Start at 1 and increasing, these are the only ways to do it. There's only 3 of them. And starting at 2, this is the only way to do it. And that'll be it. So there's only 1, 2, 3, 4, 5, 6, 7, 8 ways over this, and we'll have our probability of him getting that right. Cow 7 and cow 8 I can't do because I don't speak Vietnamese. Cow number 9, though, is a really nice question. So first I made a substitution of just u equals all of this stuff. I'm using Taylor's base change law as well, which is cool. But anyway, you put u into here, and yeah, I'm using the change base law. I'm going to put in 3s because that seems a sensible thing to do. Log to base 3 of a third is minus 1, so that just makes this a minus here and this a plus here, so that's cool. I've also made 9x squared into 3x all squared, so that I can bring the 2 down to make that a 4. And over here, log with a 2 here, it's a bit like sine squared. That just means log squared like this. So that 2 is going to come down and make that a 6 as well. Or it's not. I think I'm actually not going to do that because it turns out it's better not to. Anyway, this all makes this, that's good. And then you can very cleverly write this 1 as log to base 3 of 3. And the reason you want to do this is because this is a really hard spot, but this actually factorizes. When you put these 2 things together to make log to base 3 of 3x, because of course addition law, this thing here factorizes. Notice how this is the same as this, and this is the same as this, and then you've got squares on the outside. That's the giveaway. It factorizes to this, and that's not an easy spot, but it is towards the end of this exam paper, so it is supposed to be hard. So therefore, either this thing is 0 or this thing is 0, so we'll do that. We'll go to the next page. We can, of course, do subtraction law for logs here to make u over 3x and u over 3x here. Now, one of these things is significantly easier to solve than the other. It's this one. So let's start here. Obviously, u over 3x equals 1 because 3 to the power 0 is 1. That means u equals 3x. But u, of course, remember that original substitution I made was up there, was that. Now, you can solve this just by doing it in the dumb way, which is just squaring everything. Now, be careful of creating false solutions here. I will have to check that at the end. But yeah, I just squared everything. Expand this bracket out, you get this. Combine these 2 thirds here, and then there's some cancelling here, which is nice. You get this. And then, of course, you can isolate this square root and square it again. 2 squared is 4. This square root squared is just itself. And then square this. Again, use brackets properly. You get all of this. Eventually tidy that up to this. Divide by x squared because x can't be 0. For this log here to work, x can't be 0. It has to be bigger than 0. So I can just divide by x squared and then move the thing over and square root, and we get this here. X also can't be negative, so I'm not interested in the negative square root here either. Good, so we have that as one solution. And again, the negative I just checked by doing that. So that's the problem with false solutions dealt with. Now over here, I really don't want to expand this cubic out. So instead, I'm just going to be a bit more intelligent about it. X can't be bigger than 2 because otherwise this square root doesn't work. So the biggest x can be is 2, which means the absolute biggest this side of the equation can be is 6. However, if you look at this side of the equation, if you make x 2, you get root 4, which is 2, cubed, which is 8, and that's too big. And if you make x 0, you get root 2 plus root 2, which is 2 root 2, which cubes to like 8 times 2 root 2 cubed is what? Root 8 or something, which is way bigger than 6. And so this side of the equation is just way too big for this side of the equation. So there's just no solutions here at all. So I don't need to do any solving here. I'll just say that. Question number 10 then, and to finish up, we're going to have this thing here, expression here, or equation, and it's asking us to maximize x plus y. So I'm going to make a couple of substitutions here. I'm going to say u equals root x minus 2 and v equals root y minus 3. It just so happens if you square both of those things and then add them together, you end up with x plus y plus 1, which is really nice because that means we can say u squared plus v squared equals 2 brackets u plus v, which is cool. Expand that out and move everything to one side, and you'll notice what type of curve this is. It's just a circle because we complete the square to make this, and then we get this, and we can draw the circle down in the uv plane. Center 1, 1, radius root 2. But of course, root 2 is a really nice radius because you notice the root 2, 1, 1 right angle triangle here, making this cross at 0, 0, and also have a coordinate here of 2, 2, because it's just 1 across 1 up makes a right angle triangle of 1, 1 root 2, which is the radius. So that's great because it means the maximum u and v can be added together is going to be this 2, 2, and the minimum is going to be 0, 0. So, okay, well, if we know that u and v is 2 and 2, that makes x. If u was 2, square to get 4 equals x minus 2, so that makes x 6. And likewise for y, if v was 2, square it for 4, take away 3, get y as 1. So the maximum x plus y can be is 7. While I'm here, I'll also find, it didn't ask for it, but I'll also find the minimum of x plus y by doing by choosing this value here, u and v is 0, which gives you, of course, x is 2 and y is minus 3, to give you a minimum value of x plus y being minus 1. Now, what it's asking me next is to take this whole thing here and find some number m for which this is definitely less than this. Let's just bound it underneath this thing. Now, in order to do that, I'm going to replace this xy with the biggest thing it can possibly be. This is minus brackets x plus y, and I'm going to replace that with the smallest thing it can possibly be. And then this thing here is always either positive or 0. Now, to make this whole expression as big as possible, I'm just going to make that 0. So I'm not going to take anything away. I'm just going to say that's all 0. Now, of course, these things can't happen all at the same time, but it doesn't really matter because all I'm being asked to do is bound it underneath some number. So I'm just saying if I make this as big as possible to make this thing as big as possible, this as small as possible to make this, because when you take away a small number, you get a bigger thing. So to make this as big as possible, make this as small as possible, just say that's 0, and I'll end up with the biggest thing. I can't even possibly have it, but I'll end up with the biggest thing, even hypothetically possible, I guess we can say, which is this, and so that's therefore a bound for m, which this thing is definitely less than. And I think that's all I'm being asked to do. That's the whole paper. Thank you for sending that to me and asking me to do it. I hope that people took value out of that, and thanks for watching.